So pranam to all my seniors, colleagues and students present over here. Is the presentation visible, madam?
Yes, ma'am.
Okay. Pranam to all the seniors, colleagues, students present over this August platform. Firstly, I would like to thank the officials of Vishwa Ayurved Parishad, Professor Govind Sahai Shukla sir, Professor Mahesh Vyas sir, Professor Yokesh Chandra Mishra sir, and Dravyaguna Sambhasha team office bearers, Vaidya Meena madam, Vaidya Shraddha madam, and Vaidya Rashmi Patekar madam for giving me such a wonderful opportunity. A special thanks to my beloved senior and guide from the beginning of my career, Dr. Anil Kumar Shukla sir, who have been instrumental in arranging this lecture. So the topic of today's today's presentation is parametric tests to assess the Panchbhautiktva and Guna as per NCISM curriculum, practical aspects. So in this lecture, I aim to address the practical difficulties or practicalities one may face while preparing and conducting the experiments introduced by the new NCISM syllabus. I have prepared this presentation like a practical guide to what to do and what do's and don'ts in carrying out the practicals. I will also be dealing with the procedure in short and discussing the difficulties or points to be noted while conducting these practicals. All these practicals are very new to the teachers of Dravyaguna, and we are facing while doing this. I am also personally facing some practical difficulties. I am just pointing out these difficulties and how to face that and the do's and don'ts while doing this practicals. So first of all, parametric tests have been introduced to find out the Panchbhautiktva and Guna of a Dravya. So what are parametric tests? Parametric tests are tests that make assumptions relating to parameters. और ये एक टेस्ट है जो पैरामीटर्स को के बारे में हमें assumptions देते हैं. So what is parameters? Parameters are variables whose measure is indicative of a quantity that cannot by itself be determined by direct methods. तो पैरामीटर्स ऐसे वेरिएबल्स हैं जिसे हम डायरेक्टली मेजर नहीं कर सकते. जैसे हाइट हो, वेट हो, डायरेक्टली हम मेजर कर सकते हैं, मगर पांचभौतिकता डायरेक्टली हम मेजर नहीं कर सकते. तो उसके लिए हम वेरियस वेरिएबल्स लेते हैं एंड उसको मेजर करते हैं एंड उसके द्वारा पांचभौतिकता को एसेस करते हैं. जैसे आप अभी कोई सिंगिंग कंपटीशन हो तो सिंगर को डायरेक्टली हम एसेस नहीं करते, उसके पिच हो, टोन हो, उसके हाउ शी परफॉर्म, ऑल दीज थिंग्स वी all these parameters variables we take into consideration and then we assess her. In the same way, Panchbhautiktva can't be assessed directly, so we are taking into consideration some parameters and then assessing the Panchbhautiktva. So coming to the syllabus, for assessing Parthivatva, the parameters mentioned in our syllabus are bulk density and specific gravity.
Ma'am, sorry to interrupt. Your slides are not moving, or you're not moving the slides?
I have changed the slides, madam.
No, they're not seen, ma'am.
Okay, I will stop sharing and once more start it.
Okay.
Now is it visible, madam?
Yes, now it's visible.
The table, the slide with the table?
Yeah, slide with the table is visible. Can you put it on presentation mode?
Yes, yes, sure. So NCISM has given some activities to assess the various Panchbhautiktva. For Parthiv Tattva, they have given two parameters, that is bulk density and specific gravity, and they have also given us a choice of drugs like Asti Sringla, Sariva, Vitari, on which we can carry out this practicals. For Jaliyatva, they have given 3 parameters: viscosity, specific gravity, moisture content. And for Agneyatva, pH and moisture content is given. And for Vayavitva, fat content, specific gravity, and bulk density is given. And Akashiyatva is measured by bulk density. Guru Laghu Guna can be assessed by bulk density and specific gravity, both liquid and solid. And Snigdha and Ruksha Guna can be assessed by total fat content, moisture content, and swelling index. So for all these activities, NCSM has given a set of drugs which we can use for conducting all these drugs. And as per NCSM syllabus, NCSM guidelines, the quada or fanda of this drugs and the powder of these drugs can be used for conducting the practicals. Here, a practical difficulty that we are facing is with the Kumari, with the quada or fanda of Kumari and Ikshu. How to prepare. We were first thinking about doing the practical with Kumari Swarasa and Ikshu Swarasa, but there is practical difficulty. The others are taken as fanda, but if you are taking Kumari Swarasa, it would be a type of mismatch. So there is a practical difficulty there. Now we will come to that later. Now coming to the experiments, these are the 8 experiments that we have to conduct. So I will be dealing with how to conduct these experiments and how to minimize the whatever mistakes we may make in between conducting these experiments. So the 8 experiments that we have to conduct are bulk density, specific gravity of liquid, specific gravity solid, viscosity, swelling index, pH, moisture content, and total fat content. So NCSM, the new syllabus of NCSM is very good, very elaborate. They have even given the cognitive levels, the levels the student should be knowing. The particular point, all these things are being elaborated. And if you look into the practical session, you can see that most of the practicals is just to participate or describe or answer the methods. But you can see some practicals which has a level where the student has to show how to perform. Others are know-how. But the 3 practicals that the student should be knowing is: one is specific gravity solid, then there is specific gravity liquid, then there is pH. These 3 practicals, and also these 3 practicals, they have to show how to perform. And if you look at the practical exams also, they are supposed to do this experiment, specific gravity experiment and their pH experiment during their exams also. The others, they have to just observe, or you have to just demonstrate them how to conduct or how to show this, how to conduct these experiments. Now coming to each experiment. The first experiment is bulk density. So what is bulk density? Bulk density is the measure of mass of a material per unit volume. So from the definition itself, it can be seen that it is just the weight of the material divided by its unit.
Slides are not moving, ma'am.
Okay.
It is not in presentation mode.
Madam, is it in bulk density slide now?
No, it is presentation is not visible.
Okay. Now is it visible, madam?
Yes, now it's visible.
Bulk density itself?
Yes.
Madam, if the slide is not moving, please let me know. Bulk density is the mass or the weight of the material per unit volume, and it is commonly used to describe the compactness or heaviness of a substance. Actually, it is done in the pharmaceutic sections of the pharma industry or pharma industry for solid dosage manufacturing, packing, etc. If the bulk it is used for actually manufacturing and packing. We can think about a 500 mg paracetamol and 500 mg cotton. I am saying cotton because it is easier for you to imagine. So if you pack both these, the packings would be very different. So to find out the what the packing size should be, they use this bulk density and all. So here we are using it to find out the parthivatva, akashiyatva, vayuvatva. The principle is that if the bulk density is more, the parthivatva would be more and vayavya and akashiya tattva would be less. Now coming to the materials that we are using, of course we need to weigh the material, so we need a weighing balance. Then we need to find out the volume. For that we need a bulk density apparatus. So first, the method for doing this is to weigh a specified quantity of drug, 10 gram. You can take any number, but the number should be constant for all the samples that you are comparing, and transfer it to the measuring cylinder. Fix the measuring cylinder on the bulk density stand. Set the apparatus to the desired strokes. Desired strokes here, desired strokes is like you can start it with a 50 stroke or with a 100 stroke, and stop the strokes and see the volume, and then again give one more 50 strokes. And if the volume recorded in both the readings are same, you can stop the procedure. That's the procedure. यानी कि पहले एक बार 100 स्ट्रोक देके आप वॉल्यूम देखो, फिर से एक और 50 बार देखे, फिर से वॉल्यूम देखो. अगर ये दोनों रीडिंग सेम है, you can stop the procedure there. That is the desired strokes. Measure the volume of the sample on measuring cylinder occupied after setting it to a specified strokes, and the calculation is weight of the sample, that is 10 gram. We have taken it as 10 gram divided by the volume that you got from the bulk density apparatus. So this is the bulk density apparatus, and you can see a knob over here. Knob over here. You can use this to set the apparatus to desired strokes. Now there are digital density meters also. So in that, digital readings would be coming, and you will be having two measuring jars in this density apparatus. You can either take it's advisable to take the same sample in both the measuring jars. You can also take different drug samples in both the jars, and you have to give it desired number of strokes. First, you can give a 50 number of strokes or 100 number of strokes, and then when the weight comes to a constant, you can stop the procedure. But care should be taken that एक measuring jar आपने भरा और दूसरा नहीं भरा, ऐसे नहीं कर सकते हैं. दोनों भरना चाहिए, नहीं तो ये जो इंस्ट्रूमेंट है वो खराब होने की चांसेस है. तो दोनों में सेम पाउडर भरना वो सबसे डिसायरेबल रहता है. दो पाउडर भरना है, दो ड्रग के पाउडर भरना है, वो भी कर सकते हैं, मगर एक ही पाउडर भरना वो डिसायरेबल रहता है. अभी इसमें आपके पास बल्क डेंसिटी अपैरेटस इज लिटिल बिट ऑफ अ कॉस्टली पड़ता है. तो आपके पास ये अपैरेटस नहीं है, तो आप एक सिंपल मेजरिंग सिलेंडर से भी ये कर सकते हैं. यहाँ पे जो डेंसिटी देखा जा रहा है, ये टैप्ड डेंसिटी है. आपने टैप किया, आपने स्ट्रोक किया, उसके बाद डेंसिटी आप देख रहे हो, तो दिस इज टैप्ड डेंसिटी. आप सिंपल एक मेजरिंग सिलेंडर में ये पाउडर भर के उसको थोड़ा सा एक टैप करके उसके वॉल्यूम देख के वेट ऑफ द सैंपल बाय वॉल्यूम करना, ये भी बल्क ऐसे भी आप एक्सपेरिमेंट कर सकते हो. द प्रैक्टिकल एस्पेक्ट्स The first point is the bulk density apparatus is not available with you. It's not provided by the college. You can use a measuring cylinder also. You can tap it on a hard surface from a 1-inch height for 3 times, and then you can find out the bulk density. The one thing that you have to see in this experiment, practically आपको क्या देखना है, you have to prevent spillage of weighed powder. आपने 10 ग्राम पाउडर दिया और फिर स्टूडेंट वो डालते वक्त इधर उधर उसको स्पिल किया तो वो वॉल्यूम में चेंजेस आएंगे, तो वो प्रिवेंट करना है. उसके लिए आप ग्लास फनल या फिर एक पेपर को एक फनल जैसे बना के वैसे आप ट्रांसफर कर सकते हो. And bulk density apparatus, if you are going to buy, or if the college is asking you which type of bulk density apparatus you need, और costing निकाल के तो ऐसे कुछ है, तो इसके जो प्राइस रेंज है 5500 से स्टार्ट होते हैं, मगर डिजिटल टाइप्स जो आते हैं उसमें 33,000 तक जाते हैं. Next, coming to the next practical, specific gravity. Specific gravity हमें specific gravity liquid भी है और solid भी है. Liquid आपको जरिए तो देखने के लिए ये liquid वाला specific gravity करना है. And specific gravity क्या है? Specific gravity of a liquid is the relative weight of the liquid compared to an equal volume of the water at a given temperature. So weight of the liquid compared to equal volume of water. What you have to look over here is that equal volume of water का weight आपको देखना है as compared to the weight of the liquid. इसके लिए आप कैसे equal volume of water ही देखेंगे, उसके लिए हम एक specialized device use करते हैं, that is called the pycnometer or specific gravity bottle or density bottle. तो ये equation से ये definition से ही आपको पता चल गया होगा कि ये जो relative weight है, the weight of the liquid divided by weight of the water would be the specific gravity of that particular liquid. The materials that we want is pycnometer, specific gravity bottle, density bottle, weighing balance, wash bottle. You can use wash bottle to fill the specific gravity bottle, or if you have a filler, that will also do. So the procedure is weigh clean and dry pycnometer. It should be noted as W1. So first you are taking a pycnometer को लेते हैं, उसको weigh करते हैं, then उसको fill it with distilled water, wipe it with a filter paper. उसके sides में water चला जाता है तो उसको एक filter paper से wipe कीजिए, बहुत ही gently wipe कीजिए, and then weigh it. It is taken as W2. Now pour out the water from the pycnometer, rinse it, dry it in an oven, and then again fill the pycnometer. आपका जो फंड है, जो ड्रग का फंड है, उसको फंड या क्वाथ जो भी आप लेते हो उसको इसमें भरना है, एंड इसके वेट आपको W3 नोट करना है. एंड स्पेसिफिक ग्रेविटी अभी ऑलरेडी हमने डिस्कस किया, मैंने बताया वेट ऑफ द लिक्विड विथ divided by the weight of water होगा. तो weight of the liquid or weight of the sample is W3 minus W1. W3 जो है सैम्पल का वेट है माइनस द पिक्नोमीटर W1 द पिक्नोमीटर वेट divided by W2 minus W1. W2 क्या है? W2 is the weight of the distilled water minus this pycnometer. So this will give the specific gravity. So specific gravity is a relative constant. Now coming to the equipments, this is the empty specific gravity bottle. First you have to weigh this empty specific gravity bottle. It would be noted as W1. Then you have to take water in it, distilled water in it, and weigh it. This is considered as W2. The temperature is considered to be constant. Some pycnometers come with temperature, so you can even look the temperature of the sample and the water and ensure that both the temperatures are same. So W2 is water, and W2 is the pycnometer filled with water, weight of pycnometer filled with water. Then you have to pour out the water, dry it, clean it, dry it, and then take your sample and then weigh it. and it is called a W3, and the formula is W3 minus W1 by W2 minus W1. Practical aspects in this particular practical is that you should carefully wipe the excess water or sample from the instrument before weighing. The outer surface जो है उसको अच्छे से पोंछने के बाद ही weigh करना है, और पिक्नोमीटर को फिल करना वो भी आपको एक ध्यान रखने की। आप पिक्नोमीटर क्यों यूज कर रहे हो? पिक्नोमीटर इज यूज बिकॉज यू आर टेकिंग द इक्वल वॉल्यूम ऑफ वाटर एंड इक्वल वॉल्यूम ऑफ सैंपल, ये एंश्योर करने के लिए आप पिक्नोमीटर यूज कर रहे हो। अगर आपके पास पिक्नोमीटर नहीं है तो आप एक ग्रेजुएटेड सिलेंडर से भी ये कर सकते हो, मगर उसमें आपको जो लाइन जो है, जो वाटर के जो मेनिस्कस जो है वो करेक्टली बैलेंस करना है। आप इक्वल वॉल्यूम उसमें थोड़ा ऊपर नीचे हो सकते हैं, इसलिए हम पिक्नोमीटर यूज करते हैं। तो पिक्नोमीटर में कैसे है, आपको एकदम रिम तक पानी या सैंपल भरना है एंड उसके बाद उसको जो उसके जो स्टॉपर है उसको लगाना चाहिए। So filling pycnometer fully, that should also be done. Dry the pycnometer before filling it with sample. एक बार पानी भरा, वो निकालने के बाद अच्छे से ड्राई करने के बाद ही सैंपल आप भरिए। फिर choose the correct pycnometer. If your college gives you a chance to choose a correct pycnometer, आप करेक्ट पिक्नोमीटर मीन्स आपको जो सही अच्छा लगे यूज करने के लिए, अच्छा नहीं यूज करने के लिए जो हैंडी हो, ऐसे पिक्नोमीटर। हमारे कॉलेज में जो पिक्नोमीटर लिया उसमें एक कैपिलरी ट्यूब और ऐसे एक थर्मोमीटर भी था, और ये बहुत छोटा था, तो ये इसमें काम करना बहुत मुश्किल होता था, हो रहा है। तो ऐसे आपको अगर चांस मिले तो ऐसे बिना कैपिलरी वाला लेना ज्यादा अच्छा रहेंगे। वैसे कैपिलरी वाला ज्यादा एक्यूरेट माना जाता है, मगर बिना कैपिलरी वाला लेंगे तो थोड़ा वर्किंग आपका आसान हो जाएंगे। तो दैट इज द practical aspects of this specific gravity liquid, this particular experiment. Now coming to the specific gravity solid. Specific gravity solid, this is a bit of complex procedure. For this also the same equipments are needed. Specific gravity pycnometer, you have specific gravity bottle, you have density bottle, weighing balance और and wash bottle. So पहले weigh the empty density bottle या pycnometer with the stopper, उसको हम W1 नोट करेंगे। पहले pycnometer के empty weight को हम लेंगे, that is W1. Now add 5 gram of the test sample, transfer it to the density bottle, find the weight of the bottle and sample. बॉटल में आपका जो टेस्ट सैंपल है उसके पाउडर को भरना है एंड उसका वेट एंड पिक्नोमीटर के साथ लेना है, दैट इज द W2. नाउ ऐड सम वाटर टू द टेस्ट सैंपल, थोड़ा सा पानी डालना है इसमें एंड जेनरली शेक टू मिक्स द सैंपल एंड वाटर सो दैट नो एयर इज ट्रैप्ड। आपको अच्छे से ये जो पाउडर है उसको पानी से मिक्स करना है। क्या होता है, कभी लम्स होते हैं, नहीं तो पानी अच्छे से जाते हैं नहीं है। आप 2 घंटे तक इसको सोक करके भी रख सकते हो। सोक करके रखने के बाद फिर आगे पूरा बॉटल फिल कर सकते हो, नहीं तो एक बार हिला के सैंपल को अच्छे से आप मिक्स कर सकते हो। देन फिल द बॉटल कंप्लीटली विद डिस्टिल्ड वाटर, पुट द स्टॉपर, वाइप द बॉटल क्लीन एंड डिटरमाइन द वेट ऑफ द बॉटल एंड द कंडेंस। सो नाउ वी हैव वाटर एंड पाउडर एंड पिक्नोमीटर। W3 में पाउडर का वेट भी आ गया, पानी का वेट भी आ गया एंड द बॉटल्स वेट also has come. Now empty the bottle and thoroughly clean it and fill the bottle with only distilled water and weigh it. अच्छे से पिक्नोमीटर को धो के उसमें डिस्टिल्ड वाटर लेके उसको आपको भरना है। एंड स्पेसिफिक ग्रेविटी आप जैसे मैंने पहले कहा है, इट इज अ relative measure relative to the weight of the water. तो जो सैंपल है उसके वेट W2 minus W1 by W2 minus W1 the whole minus W3 minus W4 is the equation. हमें वो वॉल्यूम पाउडर का वॉल्यूम जो पानी पानी का वॉल्यूम जो पाउडर के वॉल्यूम से करस्पॉन्डिंग है उसका ही वॉल्यूम लेना है, इसलिए नीचे का इक्वेशन ऐसे है. ओके, coming to this is the empty meter. First you have to weigh it, then you have to fill the powder in it, you have to weigh it and put it as W2, then you have to add water. While adding the water, mix well and ensure that there is no air entrapped in it. This is noted as W3, and then pour off all the contents, wash the picnometer and dry it, and then W4 you can take only water in it and weigh it. And the equation is W2 minus W1 by W2 minus W1 the whole minus W3 minus W4. Practical aspects, ये जो practical के practical aspects, while determining W3 the sample should be fully soaked with water. यही एक चीज इसमें देखना है. आप जब पाउडर लेंगे उसमें पे फिर पानी डालेंगे तो उसमें लम्स बन सकते हैं, उसमें एयर एंट्रैप हो सकते हैं. तो if needed you can keep the sample and water for 2 hours so that the sample is fully soaked, and then add water to completely पिक्नोमीटर. पिक्नोमीटर को हमेशा फुली फिल करना है. देन यूज ए फनल, पाउडर नीचे ना गिरे इसके लिए फनल यूज कर सकते हैं, ग्लास फनल, नहीं तो पेपर फनल्स भी यूज कर सकते हैं. पिक्नोमीटर यूजुअली कम्स अराउंड 1000 रुपीज, 1000 to 1500 में आता है पिक्नोमीटर. सिग्मा-रिच जैसे बड़े कंपनीज का 9000 मीन्स 1000 ऑनवर्ड्स ऐसे बोल सकते हैं. फिर coming to the next practical, viscosity. Viscosity is the measure of a fluid's resistance to flow relative to one another. Relative to, यहाँ पे हम relative to water लेंगे, यानी कि एक fluid उसके resistance of flow compared to the resistance of flow of distilled water, that is viscosity. So the equation for viscosity is eta of the sample. Viscosity is mentioned as eta. Eta of the sample is equal to eta of water into density of sample, density of sample into time of the time taken by the sample to flow from one point of the viscometer to another point, divided by density of water and into time taken by the water to flow from one point to another. I will detail this in a while. So eta S is viscosity of test sample. Eta water or viscosity of water is taken as 9.997. It can be taken as 1 also. Density of water, again it would also be 1. Time of flow of water, density of test sample, and time of flow of test sample is TS. Now, in this particular experiment, you have to determine 2 things. First one is you need an Oswald's viscometer in which you will be determining or you will be finding out the time of the flow. And the second thing that you have to determine in this particular experiment is the density of your particular sample liquid. For the for knowing the density, you can use specific gravity bottle or picnometer, and to know the time of flow, you can use Oswald's viscometer. So coming to the so the materials needed: Oswald's viscometer, stopwatch, picnometer or specific gravity bottle, weighing balance, burette stand, pipette, and a rubber tube or sucking rubber ball. Actually, I have put this burette stand, pipette and this rubber tube in red because we usually, when we buy equipments for our lab, we usually miss out these stands, miss out these equipments. Burette stand is needed for holding the Oswald's viscometer. Rubber ball or rubber tube is needed to suck out water or the sample from the viscometer, and pipette is needed to fill the viscometer. So these all are equipments which we may miss out, and also it is not an MSR, so we won't be buying it. और जब experiment करने के लिए आएंगे तो ये सभी जो है ये practical difficulty होगा, आपको stand नहीं है तो viscometer कैसे fix करेंगे, and all this would be a practical difficulty for you. Now coming to the procedure, as I told before, we have to find 2 parameters in this test. One is the time of flow of your sample and water, and second one is to find the density of water and the sample liquid. So first, finding the time of flow, the previously find the time of flow of the sample and water, we are using Oswald's viscometer. The previously washed and completely dried viscometer is mounted vertically in a vertical position on a suitable sand. Water is filled into the viscometer, and then it is sucked. The water is sucked or blown out of the viscometer to a point above mark A. So you can see this is the viscometer. You have to put water through this water limb for transfer liquid through the this limb, and then madam, is the pointer visible?
Yes, yes, ma'am. Your
So
cursor is visible. So
yes, yes. So you have to put the liquid or the water through this limb of the viscometer, and you have to suck the water through this limb of the viscometer. So you can attach a rubber tube on this side of the viscometer so that you can easily suck out the water or the sample from the from the viscometer. So first you have to pour the water or your sample through this limb, then suck it, and you can see a mark over here. A, it is marked as upper mark or A. You have to suck it above this mark and then release it, and you have to take the time, note the time that the water has taken from to travel from A point to this B point. So time taken by the water or sample to move from or travel from point A to point B. This should be noted down, and this is the time of flow that we have seen in the equation. The same procedure will be repeated for the test sample. After that, finding the time of flow, we should find the density. For this, we have to fill a previously weighed a pycnometer fully with water, weigh the pycnometer, and find the density by this equation: weight of the pycnometer plus weight of the water. That is, after filling the pycnometer with water, you have to note down the weight as W2 minus empty pycnometer W1 by volume of water. Volume of the water would be the volume of the pycnometer, which would be mentioned in your pycnometer itself. Repeat the procedure with the test sample. So we have got density of both the sample and the water also. Now we can put it in our equation. So you can see here we can add the water by a pipette, or if you don't have a pipette, you can add the water by filler also. The Oswald's viscometer should be kept on a burette stand. Otherwise, it would be difficult for you to conduct the practical. Then you have to pour the water by a pipette or by a filler. Then the tube is connected to the right limb, and then it is sucked. The water is sucked, or the sample is sucked above the mark A. You can see the mark A here. Mark A here. It should be sucked above this mark, and then it should be released. When the water reaches the mark A, you have to start the stopwatch and note the time taken by it to travel from this point A to point B. So you have to suck the water well above the mark A, then you have to wait till it comes to the point A or the upper mark. Upper mark तक आने तक आपको wait करना है. आने के बाद stopwatch को on करना है, and then note करना है जब तक वो mark B तक पहुंचे. And this is the time taken for the sample or the water to flow from one point to other. So you can see the water flowing to mark B. Now comes the density. To find out the density, you have to first weigh the empty pycnometer and then take the weight of the pycnometer plus water or plus sample, and then you have to subtract this second W2 from W1 divided by the volume of the water, volume of your picnometer, and you can substitute this into this equation and find out the viscosity. Now coming to the practical aspects of this particular experiment, the first practical aspect is that if you're a new college, if you're not having a PG batch and all, if you're a UG college, then these instruments won't be there, and you would be buying new instruments, and new MSR also is having all these instruments. But burette stand, pipette, filler, or the sucking rubber tube, these will be missed while you are buying the instruments. These are very much important in conducting this practical. Now keep the stopwatch ready. Here you are sucking the water to upper level, and keep the stopwatch ready. Suck the fluid well above the mark A, so that there is ample time for you to start the stopwatch. Usually क्या होता है, जो water जो है थोड़े से ऊपर जाने के बाद बहुत ही जल्दी मार्क A तक पहुंच जाते हैं, हमें स्टॉप वॉच स्टार्ट करने का टाइम नहीं मिलता है. तो मेक श्योर दैट यू सक मच अबव द मार्क ए एंड यू गेट एम्पल टाइम टू स्टार्ट योर स्टॉप वॉच.
Ramanandan Sahani, Dr. Ramanandan Sahani, please mute yourself. Dr. Sahani, please mute yourself.
Okay.
So suck the fluid well above the mark A, and so that you get an ample time to start the stopwatch. Otherwise you would miss the mark A. Mark A तक जब तक वाटर आ जाएंगे तब तक आप स्टॉपवॉच शुरू नहीं कर पाएंगे. तो उसमें एक ध्यान रखना है. फिर तीसरी बात जो आपको ध्यान रखना है, दैट इज एयर बबल्स. यू कैन सी एयर बबल्स दिस वुड बी एंट्रैप्ड इन विस्कोमीटर. वो आपके रीडिंग लेने में आपको दिक्कत होगी और सब करने में भी आपको दिक्कत होंगे. तो ऐसे एयर बबल्स एंट्रैप ना हो, उसके भी ध्यान रखना है. कैपिलरी ट्यूब, यहाँ पे आप देख सकते हो कैपिलरी ट्यूब जो है वो थोड़ा छोटा है, इट्स वेरी स्मॉल. सो विस्कस अगर आप कुमारी का ये सब कुमारी का स्वरस या कुमारी का ये फंड प्रिपेयर करते हो, तो आप उसकी जेली या फिर ऐसे कुछ उसमें गिर गया तो वो एक कैपिलरी ट्यूब में आके वो फंस जाएंगे एंड कैपिलरी ट्यूब विल नॉट बी वर्किंग. तो वो एक आपको ध्यान रखना चाहिए. इसमें जो कुमारी का जो प्रैक्टिकल है उसमें आपको थोड़ा ध्यान रखना है. कुमारी में आप जो जेली पार्ट जो है वो आना नहीं चाहिए, क्लियर जो लिक्विड है वो ही आना चाहिए. फिर more viscous fluids won't pass through this capillary tube, and the price of this viscometer is usually from 1650 to 1850. Certified ones, there are some certifications for this viscometers, and certified one will be costing about 3,500 rupees. Now coming to the next practical, pH analysis. pH is the measure of the concentration of hydrogen ions in a solution. For this, you will be needing a pH meter, a beaker, and buffer solutions. So the procedure of the experiment is, first you have to calibrate the electrode using standard buffer solution. pH analysis में एक बात जो आपको ध्यान रखना है, ये जो calibration एक ही point है जो pH analysis में बहुत ही important है और आपको ध्यान रखना है. जब भी आप रीडिंग लेते हो उसके पहले आपको इलेक्ट्रोड को बफर सॉल्यूशन से कैलिब्रेट करना है. एंड बफर सॉल्यूशन आपके जो पीएच मीटर आप लेते हो उसके साथ मिलता है, नहीं तो इट इज आल्सो अवेलेबल लूज इन द मार्केट. वॉश द इलेक्ट्रोड यूजिंग डिस्टिल्ड वाटर एंड क्लीन इट विथ टिश्यू पेपर. इलेक्ट्रोड को अच्छे से टिश्यू पेपर से रब करना है, रब करके उसको क्लीन करना है. देन टेक द सैंपल सॉल्यूशन ऑफ रिक्वायर्ड कॉन्सेंट्रेशन इन सूटेबल अपैरेटस. बीकर में आप suitable beaker में required concentration of sample solution, required amount, sorry, not concentration, required amount of sample solution लेना है, and then immerse the electrode in solution so that the porous part is inside the solution. Wait for 5 minutes and read the pH value. So you can see ये जो है ये पुराने टाइप के pH मीटर है. ये नया डिजिटल आया है. डिजिटल में ऐसे कुछ ज्यादा दिक्कत नहीं आती है क्योंकि ये डिजिटल स्क्रीन में भी ही आपको जो प्रोसीजर है वो लिख के दिखा जाएंगे. आपको 4 pH रखने के लिए बोलेंगे, 7 बफर सॉल्यूशन रखने के लिए बोलेंगे. ऑल द इंस्ट्रक्शंस आर गिवन इन इट इटसेल्फ. सो आपको वो इंस्ट्रक्शंस फॉलो ही करना है. एंड जब स्टार्ट करेंगे तो आपको एक pH मोड में, यहाँ पे आप देख सकते हो 3 मोड है, स्टैंड बाय मोड, pH मोड एंड MV मोड. तो आप जब pH मेजर करते हैं तो pH मोड में आपको मेजर करना है. एंड ये कैलिब्रेशन जो है, कैलिब्रेशन स्विच कैलिब्रेशन नॉब इसे बोलते हैं. कैलिब्रेशन नॉब के सहायता से, हेल्प से आप उसको बफर सॉल्यूशन के सेम pH रीडिंग में ला सकते हैं. यानी कि पहले आपको 7 वाला बफर सॉल्यूशन बीकर में रखना है, इलेक्ट्रोड को इमर्स करना है एंड देन स्विच द pH मीटर टू द pH मोड. pH मोड में इसको टर्न करना है एंड देन कैलिब्रेट योर रीडिंग टू 7. ये कैलिब्रेशन जो स्विच है, नॉब है, उसके सहायता से ये जो रीडिंग है इसे 7 में लाना है. फिर उसको टेक आउट करना है, इलेक्ट्रोड को अच्छे से रिंस करना है, क्लीन करना है एंड देन pH 4 वाला सॉल्यूशन आपको रखना है. इलेक्ट्रोड को फिर से इमर्स करना है. इसके बीच में ये जो स्विच है ये स्टैंड बाय मोड में होना चाहिए. फिर से उसे pH मोड में लाना है. आपको कैलिब्रेट करके उसको 7 में, रीडिंग को 7 में लाना है. इसके बाद आप आपके सॉल्यूशन जो सैंपल सॉल्यूशन है उसको रख के आप एक्सपेरिमेंट कर सकते हैं. एंड टेम्परेचर इज यूजुअली केप्ट एट 25 to 27 डिग्री सेल्सियस. वो रूम टेम्परेचर होते हैं. बफर सॉल्यूशन ऐसे सॉल्यूशन जैसे भी मिलते हैं, नहीं तो एक बोतल में एक कैप्सूल मिलेंगे. वो कैप्सूल को आपको ओपन करके डालना है और जो बॉटल है उसको पूरा डिस्टिल्ड पानी से भरना है और उसको शेक करके एक सॉल्यूशन बनाना पड़ेगा. नहीं तो आपको रेडीमेड सॉल्यूशन भी मिलता है. यूजुअली कैप्सूल्स मिलने की चांसेस है. आप एक pH मीटर लेंगे तो उसके साथ एक बॉटल और एक कैप्सूल मिलने की चांसेस ज्यादा है. ये अगर pH मीटर डिजिटल, ये pH एनालिसिस मीटर नहीं लेते हैं तो आप एक पेन टाइप pH मीटर भी ले सकते हो. कैन ऑल्सो यूज ए पेन टाइप pH मीटर. उसके रीडिंग्स उतने एक्यूरेट नहीं होंगे, फिर भी आपको जो पैरामेट्रिक टेस्ट है, पंचभौतिकता एनालिसिस आग्नेयत्व के लिए है, ये भी यूज कर सकते हैं. आप पेन टाइप pH मीटर भी यूज कर सकते हैं. इसमें भी सेम कैलिब्रेशन करना बहुत ही इम्पोर्टेंट है. हर बार आप करेंगे उससे पहले कैलिब्रेशन करना बहुत ही इम्पोर्टेंट है. तो प्रैक्टिकल एस्पेक्ट्स, ये जो pH एनालिसिस में आपको जो देखना है, दैट इज कैलिब्रेशन. The one point, very important point, is that you should calibrate your equipment before the experiment. Calibration में पहले आपको pH 7 वाला कैलिब्रेट करना है, यानी कि न्यूट्रल सॉल्यूशन को पहले कैलिब्रेट करना है. देन गो फॉर 4 और 9 के भी सॉल्यूशन आते हैं, 9.2 का भी सॉल्यूशन आते हैं, उससे भी आप कैलिब्रेट कर सकते हो. इन बिटवीन द मेजरमेंट्स कीप द pH मीटर इन स्टैंड बाय मोड. टेम्परेचर आपको 25 to 27 के बीच में सेट करना है. इफ देयर इज अ स्विच टू मॉडर्न डिजिटल वंस डजंट हैव सच अ स्विच, सो उसमें फिर आपको टेम्परेचर की ये प्रॉब्लम नहीं होगी. अगर टेम्परेचर की स्विच है तो उसे 25 to 27 में रखना है. डोंट रब द इलेक्ट्रोड टू मच विद द टिश्यू पेपर. इलेक्ट्रोड इज द मोस्ट इंपॉर्टेंट पार्ट ऑफ दिस pH मीटर एंड वंस इट इज डैमेज्ड योर pH मीटर इज ऑफ नो यूज. तो उसको बहुत ही ख्याल रखना है. एंड एक्सपेरिमेंट करने के बाद उसको ड्राई नीचे रखना नहीं है, उसको KCl सॉल्यूशन, पोटेशियम क्लोराइड सॉल्यूशन में डिप करके ही रखना है, ताकि जो इंस्ट्रूमेंट की लाइफ है वो ज्यादा हो सकते हैं. रिंस विद द distilled water in between the measurement. don't disturb the calibration button or the slop button. These are the two buttons which we used for calibration. So ये दोनों button को after calibration don't disturb these buttons. Pen type pH meter also should be calibrated before experiments. So the price of these pH meters are around 10,000, but some of the pH meters are costly. More than up to 35,000 is there. Pen type you will get around below 1,000 also you will get, and also now there is a fashion of drinking alkaline water and all. So pH meter अभी बहुत ही आसानी से Amazon में कोई भी पोर्टल में आप वो मिल सकते हैं, 250 400 में भी मिल सकते हैं, but the usual cost is around 1,000 rupees. Now coming to the next experiment, swelling index. Swelling index is a quantitative measure used to describe the amount of swelling or water absorption of a material. एक सब्सटेंस कितना पानी अब्सॉर्ब करते हैं ये देखने की एक एक्सपेरिमेंट है स्वेलिंग इंडेक्स. इसके लिए आपको सिर्फ एक 50 ml मेजरिंग सिलेंडर विद ए ग्लास टॉपर यही चाहिए. So 2 grams of the sample is transferred to this 50 ml measuring cylinder. 50 ml ही होना है ऐसे कुछ नहीं है, कोई भी एक measuring cylinder आप ले सकते हो. उसमें add 25 ml water to the measuring cylinder. Volume occupied by sample is noted. It is noted as VK. The measuring cylinder was agitated occasionally and kept for 24 hours, and volume occupied by the sample is noted, and swelling index is VW minus, यानी कि 24 hour के बाद जो वॉल्यूम है VW minus VK, and उसके परसेंटेज आप VW minus VK by VK into 100 ऐसे आप नोट कर सकते हैं. स्वेलिंग इंडेक्स आपको लेना है तो VW minus VK ऐसे भी कर सकते हैं. इंडियन फार्माकोपिया में 1 gram ऑफ ड्रग kept for 4 hours ऐसे एक दिया है, तो आप वो प्रोसीजर भी फॉलो कर सकते हैं. 1 ग्राम ड्रग लेना है, उसमें पानी डालना है, उसको 4 घंटे तक रखना है, एंड 4 घंटे के बाद वो कितना स्वेल हुआ है वो वॉल्यूम देखना है. सो फर्स्ट यू हैव टू मेजर द sample, then you have to transfer it to the measuring cylinder. वो स्पिल ना हो ऐसे सावधानी से आपको ट्रांसफर करना है. उसमें पानी डालना है, 25 ml ऑफ पानी डालना है, अच्छे से शेक करना है. आप देख सकते हो यहाँ पे सरफेस में बहुत सारे सब जो भी ड्रग है ये फ्लोट करने की चांसेस है. उसको अच्छे से शेक करना है, वो सेटल करना है, सेटल होने देना है, एंड देन you have to take the reading, and after keep it for 24 hours and then take the reading. This is the swelling index. Practical aspects जो है इस practical में, ये वैसे बहुत ही आसान एक practical है. इसमें shake vigorously every 10 minutes for 1 hour. एक 10 मिनट पहले के 1 घंटे में बीच में shake.
डॉक्टर धन्य,
हाँ,
please continue your presentation in English. Some of the participants are not able to understand Hindi. So
Okay, madam. Okay. So shake vigorously every 10 minutes for 1 hour. You have to shake the bottle for the first 1 hour. You have to shake it. Shake this measuring jar in between so that all the sample settle down. Release any large volume of liquid retained in the layer of drug and any particles of the drug floating at the surface of the liquid by rotating the cylinder about the vertical axis. You have to rotate the measuring jar so that if there is any gel type thing or liquid being trapped in between 2 layers of mucilaginous substance. You can see mucilaginous substance like this. If there is a layer of water in between these 2 layers, you have to shake or rotate the measuring cylinder and release that water in between these layers so that you get a correct measurement. Now coming to the next practical, moisture content. Moisture content is the quantity of water contained in a material. Moisture content is the water or the moisture present in a particular sample. The materials used for this practical is, or the equipments used for this practical is hot air oven, crucible, crucible or evaporating dish, desiccator, and weighing balance. So first you have to take a clean, dry evaporating dish and note down the weight, and it should be tiered. Tearing, you may be knowing that procedure. You can push the button, tear in your weighing balance so that the weight comes to 0. Now take 10 gram of accurately weighed drug without preliminary drying. You should not be drying the drug before the experiment. You have to take the drug as it is, and then you have to weigh it, accurately weigh 10 gram of it. It is taken as W1. This weight is noted as W1. Now dry it in the hot air oven. You have to keep it in the hot air oven at 105 degree for 1 hour. 105 degree, you have to set the temperature to 105 degree and keep it for 1 hour. After this period, you have to take it out, keep it in a desiccator. Desiccator, I will be showing that. You will be knowing that particular instrument. You have to keep the sample in the desiccator for a few minutes so that the sample is cooled, and then after cooling you have to weigh. Now you have to repeat this procedure for say half an hour more, and note the weight, and if both the weights are same, you can stop the experiment. If both the weights are not same, then you have to continue it for 10-15 minutes and again weigh, note the weight till the weight becomes constant. Continue the drying and weighing process at 1 hour interval until constant weight is reached, and this weight is noted as W2. So we have noted W1 and W2. W1 is the drug plus drug before it is being kept in the hot air oven, and W2 is the weight which is taken after keeping it in the hot air oven. So the calculation is W2 minus W1 divided by W1, that is the weight of the sample, into 100. So loss of weight after drying divided by the total weight of the sample taken into 100. That is the percentage of moisture content. So this is the crucible. After tearing it, after keeping it in a weighing balance, tearing it, you have to accurately weigh 10 gram of sample. You can take how much amount that the 10 gram is not mandatory. You can take as much needed. Then 10 gram of this sample is taken. It is kept in hot air oven for at 105 degrees Celsius. There is a temperature knob over here. You can adjust it to 105 degrees centigrade and keep it for 1 hour, and then take it, keep it in the desiccator. Keep it in the desiccator, allow it to cool, and then take the weight. This is noted as W2, and you have to subtract W2 from W1 divided by W1 into 100. That is the moisture content. So practical aspects in this experiment is you should be using clamps or gloves to remove the evaporating dish from the hot air oven. Otherwise, you can hurt yourself. So use clamps to remove the hot air evaporating dish from the hot air oven. Cool the evaporating dish before weighing. You have to cool it properly before weighing. And one more thing that is important is desiccator. Desiccator should be you should add a suitable desiccant in this desiccator so that the moisture content is absorbed from the sample. The price of the desiccator, 18-inch into 18-inch into 18-inch desiccator is 14,300. Desiccator is around 2,500 rupees. Now coming to the last practical, that is fat content. The amount of fat present in a substance is called a fat content. The materials or equipments needed in this practical is oscillate extractor, weighing balance, round bottom flask, evaporating dish, petroleum ether, heating mantle, glass beads, filter paper, water bath, hot air, oven. So in this particular experiment, we are finding out the fat present in the substance. You are taking an organic substance. It has cell walls. The cell walls, is made up of phospholipids. So lipids are there in this particular sample in many form. You have to find out all this lipid, the amount of the lipid in fat in this particular substance. For this, you have to extract this substance with the particular solvent and take out all the fat and then weigh it so that we can find out how much fat content is there in this particular sample. So first you have to take a 4 gram of air dried crushed powder in a clean extraction thimble of Saucelet apparatus. Connect the round bottom flask of extractor with thimble and condenser. Add 250 ml of petroleum ether. The petroleum ether, the boiling point is 40 to 60 degrees Celsius. So you would be setting the heating mantle to about 60 degrees Celsius. Continuous extraction apparatus, Saucelet extractor will run for 2 hours. Later cooled it to room temperature, then filter the extract quantitatively into a tiered evaporating dish and evaporate off the solvent on a water bath. Dry the residue at 105 degrees Celsius to constant weight. As we have seen in moisture content, you have to dry the residue to a constant weight. Now the calculation is total fat content is the weight of the residue divided by total weight of the sample taken into 100. The weight of the residue that you got at the end of the experiment divided by the total weight of the sample that you have taken, that is 4 gram into 100. That would be the total fat content. So the most important part in this particular experiment is the Saucelet apparatus and the arrangement of assembling of Saucelet apparatus. This is the parts of a Saucelet apparatus. You can see there is a round bottom flask in the lowermost part. Then there is an extractor in the middle, round bottom flask. Here it is the round bottom flask. Then there is an extractor where you are going to place the drug. Then there is a condenser for cooling the vapors which is coming out from this round bottom flask. So assembling this Saucelet apparatus, first you have to take a heating mantle. Heating mantle should be of the same capacity or a little higher capacity as that of your round bottom flask. Suppose you have a 300 ml or 500 ml round bottom flask, your heating mantle should be at least having 500 ml capacity. Fix it correctly. This apparatus, this whole setup is a little bit of shaky, so the round bottom flask should perfectly fit into the heating mantle. Now prepare a drug thimble. Drug thimble means the drug should be packed inside a thimble which is readily available, which you can buy or you can make with the use of filter paper. While you making this thimble, it is advisable to use Wattman filter paper rather than any usual filter paper so that it doesn't break. Then to this round bottom flask, you can attach the extractor. This is the extractor, and keep the thimble inside this. Keep thimble inside this after filling it with drug. The drug also, if it is fine powder, it is going to become a cake. Caking will happen. So using coarse powder would be more efficient in this method. And also some people use cotton below and above this thimble so that the sample doesn't fall into the round bottom flask. So during keeping this thimble, the thimble should be kept below the level of this vapor tube. The solvent is being filled in this round bottom flask. It is going to evaporate by the heat of this heating mantle. The vapor is going to rise through this vapor tube and then go here and then condense and fall back into this extractor. So the thimble should be below the level of vapor vapor tube. Now keep a condenser above this extractor and connect the water pipes. Water pipes connecting is also important. The inlet pipe should be in the lower level and the outlet pipe should be on the upper level. So the cool water is coming through the inlet pipe. It is circulating, going to the upper pipe, and then it is going out. So the like this. And the mandle should be, the temperature of the mandle should be is equal to or a little bit above the boiling point of the solvent that we are using. Here we are using petroleum ether. Its boiling point is 40 to 60 degrees Celsius. So you can keep it 50 degrees Celsius or 60 degrees Celsius. Some glass pieces or some porcelain pieces are also put in this round bottom flask. It is to avoid the bubbling of the solvent solvent system. If the solvent bubbles and gets into this vapor tube, it is not advisable like that. So you have to add some porcelain pieces. You can use the broken crucibles for that, or some glass pieces should be put in the round bottom flask so that the bubbling of the bubbling of petroleum ether doesn't happen during the extraction process. And the solvent is added through the top of the saucelet apparatus, and the water is the tap is start the tap, and the water is continuously run in the condenser. The heating mantle, I already told that the temperature should be set a little above or equal to the boiling point of the solvent. For pet ether, it is 50 degrees Celsius or 60 degrees Celsius. Then the extraction slowly starts. The vapor, the solvent starts to evaporate from this round bottom flask. It goes through this vapor tube, comes to the above part of the extractor, condenses because of this condenser, and falls back to the thimble. And the solvent in this thimble rises slowly, and then through the siphon tube, it is going to fall back into the extraction tube. And this process will be continuously run. This whole process, from the vapor rising up to the solvent condensing, falling into the thimble bag, and then siphoning through the siphon tube to the round bottom flask. This whole process is counted as one cycle. So for fat extraction, you may be needing around 40 to 60 cycles for fat extraction. One major problem that you would be facing is continuous water. Keeping continuous water through the whole period of time, it would be difficult in places where water supply is not that constant. At the end of the experiment, you will be getting an extract like this. Now you have to take it in an evaporating dish, and then as we have done in the moisture content, we have to evaporate off all the remaining solvent and weigh the extract. So practical aspects in this there are a lot of problems in this particular experiment. Assembling the saucelet apparatus is a bit of problematic step. Assemble it properly. Put glass beads or broken porcelain pieces to prevent bumping. While boiling, the solvent can bump and get into the vapor tube. So to avoid bumping, you have to put some glass beads or broken porcelain pieces. Thimble should not be at higher level than vapor outlet tube. The thimble is the portion where you keep your drug. Thimble is your drug packet. It should be not above the water vapor outlet tube. Then use cotton below and above thimble. Below you are keeping cotton so that the drug should not be falling into if the fine powder of the drug is there, it may fall into your extraction solvent. So to prevent that, you can put a cotton below the thimble, and you can put a cotton above the thimble also, so that the condensing vapors correctly fall onto the does not fall onto the pimple and break it. Now, inlet pipe below the outlet pipe. Inlet pipe should be connected below, and the outlet pipe should be connected above in the condenser. Proper taps should be there in the labs. Most of the labs, maybe sometimes if the labs are not properly constructed, it won't be having tube pipes like this. So it would be difficult for you to connect the inlet water tube. So you have to approach your college and tell them to make a proper tube so that you have a correct piping system. Switchboards should be near the taps so that you can switch on the mandle also. The mandle and the water, you have to be both should be nearby only. So you have to need a switchboard near your wash basin so that you can switch on the mandle, so that you can plug in the mandle. So the price of Socelet apparatus is 2,200 for 500 ml flask and 200 ml extractor. In general, what are the practical aspects that you should be looking into is that you should be buying labwares, though it may not be mentioned in MSR or MSR. You should be buying this common labwares like test tubes, beakers, measuring cylinder, graduated cylinders, glass rods, stands, tubing. Stands, tubings are they are not mentioned in the MSR. So you should be buying a burette stand. You should be buying tubings for the Socelet apparatus and also for the viscometer. Then laboratory thermometer. If you have to check the temperature inside the hot air oven, a laboratory thermometer, you would be needing a laboratory thermometer. Laboratory thermometer are like a long thermometer, 30 centimeter long thermometer. So you should be buying that also. These will ease the lab operations. Lab operations will be eased by buying all these things. So I express my heartfelt gratitude to all the staff of Sumandeep Ayurveda College and Hospital, especially to my department mate, Dr. Kajal Redadia, who helped me in taking photos and doing all these experiments. Dr. Vaidya, Dr. Shraddha, of Rashastra department, and also to the staff of Department of Pharmacy, Sumandeep Vadodara, who helped me a lot with understanding all these procedures and sharing with me valuable knowledge. So to the end, I would say that learning is a continuous process, and I am happy that I could share some of the small insights that I have gained in this journey during the course of this journey. I once again thank myself for giving me this opportunity. Also, I would like to thank and congratulate the syllabus committee members, Dr. Yogini Kulkarni Madam, Chairman Manjunath Sir, Hegde Sir, Dr. Om Prakash Raut Sir, and Dr. Pramod Sir for incorporating modern analytical experiments in the syllabus. BMS students are also getting an insight in the modern analytical experiments. That's a good thing. I hope that this presentation of mine has added some knowledge to your understanding. Thank you for your patient listening.
Thank you very much, Dr. Dhanya, for nicely explaining all the experiments. Now the forum is open for the discussion.
Madam,
Dr.
may I?
Doctor, yes, sir.
Yes. Dhanya madam.
Yes, sir.
Viscosity mentioned in syllabus is of
Yes.
kinematic type. Yes. And procedure described by you is suitable for relative or absolute viscosity. So it is totally contradictory explanation. So why should we not go for kinematic viscosity explanation instead of relative viscosity?
Sir, my understanding of this is that kinematic viscosity is the viscosity measured by movement. movement of the
No,
drug in
both.
that viscometer.
Let me explain, madam. Both viscosity are yes, I agree totally. Moment, but formula to calculate kinematic viscosity is different, and formula to calculate relative viscosity is totally different. As per
Okay, sir.
syllabus, we have to calculate kinematic viscosity, and its formula is totally different. This actually formula given in syllabus for kinematic viscosity is also wrong. So
Actually,
these
I have
things.
taken this procedure from a guide which Manjunath sir and Dr. Gupta has published. So the
I
procedure given in that particular practical in that particular practical, I have taken that, and while I browsed through the net, I could find that this is kinematic. The movement, the viscosity which is measured through movement is kinematic viscosity. Yes.
This discrepancy, I have already talked to Dr. Manjunath sir. They agree that in syllabus it is wrongly mentioned procedure, and
Okay, sir.
as
So
well as
so it's a new insight for me also, sir. So I
So
I
Dr.
was
Lungare
following
sir's inputs
Dr.
are welcome. So Dr. Sanjay Lungare sir is senior person. His inputs are welcome. So next query, please.
Actually, Oswald viscometer for kinematic is totally different. It is a modified Oswald viscometer to calculate kinematic viscosity. I have
Okay.
already suggested my suggestion sent to university and Dr. Manjunath sir. So I request Dr. Manjunath sir or those members who are related with syllabus. So please correct the mistake or loophole that is written in syllabus. Even procedure is wrong, and for kinematic viscosity, and formula is totally wrong. तो क्या
So
होता है
Dr.
सभी.
Sanjay sir, Dr.
हाँ
Sanjay
जी
sir,
सर.
your
हाँ जी
inputs
सर.
are welcome. Your inputs are welcome. So we are running out of time. So please share your inputs, whatever share to Dr. Manjunath in the group also. So we research persons also recommend and write to NCISM to incorporate the same. So please share your inputs.
Kinematic viscosity totally
Yeah.
different है सर. It is
Yeah, okay, sir.
formula.
Yeah, we came
चलेगा.
to know that. We came to know that, and because we are running time, 8:30 is our closing time.
Yes, yes.
So
Okay,
please
okay, sir.
share your inputs, sir. Please share your inputs. And future, we have your
Sir,
own lecture also
thank
for
you for
lecture.
your
Yeah.
input, sir. Thank you
Okay,
for your
okay, sir. Thank you, sir.
input.
Thank you. Okay, sir.
Dr. Shweta. Okay. Any query?
Please proceed forward, madam. Please proceed.
Okay, no. Sir, okay, there is no any query. So I would like to thank full to all the senior faculty member who are joining here. Respected Rakesh Tiwari sir, Harishankar Mishra sir, Dr. Shahjahan sir, Dr. Lungare sir, Mansi Deshpande, and of course our driving force Anil Shukla sir. So I would like to thank to all senior faculty members, their support and inputs, and Dr. Dhanya for your nicely presentation. And we will again meet in next month for our next meeting of Vishwa Ayurved Parishad Dravyaguna. Thank you. Thank you.
Thank you,
all.
madam. Thank you for the opportunity, madam.
Yes, thank you. Sir, shall we stop now?
Yes, please. Santi mantra, madam, please.
Okay, 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 sir. ॐ सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत्. ओम शांति शांति शांति.